So in this video, we're going to be graphing this function here, where instead of multiplying x like I did in the last video, which changed the frequency in the period, I'm going to either add or subtract something from x. And we're going to take a look at what that's going to do to our graph, our standard sine graph. But before we get to this example, let's go back and look at something familiar. All right, so you should remember from earlier in the semester that if we took our standard parabola, okay, y equals x squared, we should know that in this case, this one shifts it down 3 units. All right, just like when we were working with the sine curve, right? Like if we had y equals sine x minus 3, that took my standard curve and it just took every point from that curve and shifted it down 3 units. Okay, so same idea that between these two. Now, recall what happens here, right? If I subtract from the 3 from the x, that takes my standard parabola and it moves it, and this feels backwards to some people. Some people see minus 3 and they want it to go to the negatives, right? But this takes my standard parabola and shifts it to the right 3 units. Or if I worked with, in the last video, I refreshed you with this function, right? This is one of our functions we were supposed to know. That looks like that. Okay, if I were to add 2 at the end, that would shift it up 2, right? But if I am to add 2 under the radical, right, add the 2 to the x and then take the square root, what this does is it takes my function and shifts it to the left 2 units. Okay, so based on what I just said with this example here and this example here, what do you think is going to happen in this graph? Okay, so again, if you can recognize structure in repeated reasoning, right? So if you can take what's happening in these familiar examples and try to apply it to this new case, then I hope you recognize that this is going to take the sine curve and it's going to shift it horizontally. All right, but to examine how and why that works, let's go back to the table of values. All right, and so just like we did in the last clip, all right, here's my x, and this time I'm going to have x minus pi over 2. All right, so I'm going to take every x value and I am going to subtract pi over 2 from it. And again, I'm going to focus on just this half of the graph. Okay, and oh, I forgot to set this up. Last time I had it set up before I started the video just so that you wouldn't have to watch me do this, but I'm getting pretty fast at working with these here. So that's my 3 pi over 2. So 0, this is my x, take away pi over 2 is negative pi over 2. Pi over 2, take away pi over 2 is 0. I could think of this as 2 pi over 2, right? Pi is 2 pi over 2 to get a common denominator. 2 pi over 2 minus 1 pi over 2 would leave me with 1 pi over 2. 3 pi over 2, take away 1 pi over 2, leaves me with 2 pi over 2, right, which is just pi. And then this would bring me to 3 pi over 2. So now, when I go to find the sine of x minus pi over 2, okay, well, look up here at what's in red. The sine of negative pi over 2 is negative 1, but now this negative 1 occurs at x equaling 0. Okay, and then sine of 0 is 0. Okay, so what is happening here as I go through this is this has shifted now over to the right. Okay, this 0 is now here. And then let's see, sine of pi over 2 is 1. But now this has shifted here, right? So I can see how I'm shifting everything to the right. And this would be 0, and this would be -1. Okay, so to finish my sine curve, right, my sine curve, one standard sine curve, I'm going to have to go another quarter here, right, because my standard sine curve goes from 0 up, back to 0, down, back to 0. Okay, so let's see, at 0, I'm at -1. This is at 0, at 1, 0, -1. I'd have to add another quarter here to complete my full cycle of the sine curve, right? So I didn't change the period. It still takes me 2 pi to get a full cycle, right? The period didn't change, the frequency didn't change, but what happened is I've taken my standard sine curve. If I were to graph my standard sine curve in green here, I've taken my standard sine curve and I have shifted it over to the right, pi over 2 units. Okay, and I certainly could connect these points here to show you. Right? I mean, I would still have those. I kind of like this graph without it so that you can see a little more clearly how I've taken this curve in green and shifted it to the right, pi over 2 units. So what I want you to do next is I want you to go to Desmos. I want you to graph y equals sine x, y equals cosine x, and then in the third line, put in cosine of pi minus, or cosine x minus pi over 2. Okay, so again, that's going to be a shift to the right. And you're going to feel like one of the graphs vanished, but it didn't. Okay, so you'll be able to see what this is equivalent to. And if you feel like one of the graphs have vanished, go up, click on sine, right? And then it'll change color. Every graph is a different color. So if you click on the graph you want to look at, it'll light up in the color that's marked on the left-hand side in that little circle. Okay, so play around with that. And then I'm also going to send you to a website where you're going to play around a little bit more.